Hello everyone, welcome back. So today we're talking about heaps. Now what is a heap? A heap is a data structure. Now there can be two types of heaps. There can be a min heap and a max heap. Now, but what is actually a heap? A heap is that form of data structure whereby you have nodes. It's usually like a tree. But in this case, the top node or the head node has to be less than or greater than. That's for a min heap, meaning that the top nodes or the parent nodes have to be less than their child nodes. That's what a min heap is. The parent node is usually less than the child nodes. Like for example, this is the parent node of 4 and 8. So 2 has to be less than 4 and also it has to be less than 8. That will be a min heap. So the same as now, this is also a parent node. It has children and it has to be less than its children. This is also a parent node. It has to be less than its child. 9 is also a parent node and it has to be less than its child. 15 and 20. That is now what you call a min heap. Now a max heap is whereby the parent node is greater than its children. That's where you have a max heap. So now, how do you implement a heap? Now usually when you're implementing a heap, we could define individual nodes that point to 4 and point to 8, but in that case it will be hectic. In this case we are going to use a list. So how do we use a list? When you're using a list, we shall have the first node here would be at index 0. Then these nodes here in this line would be at index 1 and index 2. These nodes in this line will be at index 3, index 4, index 5, index 6. And these last nodes here will be at index 7, index 8, and index 9. But now, when you put them in a list, they will be like this in a list: 2, 4, 8, 9, 7, 10, 9, 15, 20, 13. And they would be labeled from index 0, 1, 2 until the last index, which is usually a 9 in this case, which we have. But now you would ask the question, when we are now in a list, how do we keep track of the parent and the child? Like, how do we know that? Like, for example, 9, how do we know 9's parents and its what? And its parent and its children. How do we know? How do we keep track of that? So we use usually a simple mathematical formula. If we have an index and we want to find the parent of that index, what we do, we get the index minus 2, then we divide it by 2. If we want to get the left, we have an index of a certain node and we want to get its left node, we get the index times 2, then we add a 1. If we have an index and then we want to get the right, we want to get the right node or the index of the right node, we get the index which we have, we multiply it by 2, then we add 2. That's to get the what? The right node. So that is a simple way what a heap is. Now how do we start by implementing what a heap is? So to implement what a heap is, you can open your your text editor. So in this case, I'm going to implement the heap in Python. So I open my text editor, start a new file, and I can save my file. I want to save my file as heaps.py. So then I'm going to start defining my heap. Now, to define my heap, I'm going to call my class. Then I'm going to call it heap. Then I'm going to initialize init. Then the init will take in self. Then what I'm going to do, I'm going to check the size of the what? I'm going to make a list. That's my list, which will have, not checking the size, sorry for that, but I'm going to make a list which will have my elements in the heap. So I'm going to call it items. Then I'm going to have to define certain functions. So in this case, they're the same way I explained them. So I'm going to just pick them and paste them here. Then I'll explain what they are to save time. So I'm going to define a function. Let me tab this. I'm going to define a function get left child index. So in this function, if I have an index and I want to get the left child of that index, this function will return for me the left child, as I had explained before. This one will return for me the right child. This will return for me the parent child. Then this one is going to check whether it has a left child. This one is going to check whether it has a right child. This one is going to check whether the index has a parent. Then this one here is going to return for me the left child. It's going to return for me the left child. This one is going to return for me the right child. That's if I pass in an index, it will return for me the right child of that index. So if I pass in an index to this function, it is going to return for me the parent of that index which I've passed in. Then I'm going to have a swap function. Now my swap function, I'll pass in two indices which I want to swap. So index 1 and index 2. So I'll store my index 1 in this variable index 1, store my index 2 in this variable index 2. Then at the position of index 1, I'll put in index 2. At the position of index 2, I'll put in index 1. So that is the simplicity of these functions. They're going to come in handy later on in the code. So now I'm going to have to define another function. So this function is going to be called pick. What it does, it will just return for me the first element in the heap, or the smallest element in the heap. That's the first element. So it will take in just take in self. Then I'm going to check if the length of self dot items, meaning that if the length of the list is equal to 0, there is nothing in the list, not 90. If it's equal to 0 and there is nothing in the list, what I should do, I should just print maybe something like empty. Then I just return, meaning that there is nothing in the list. I go to the next line, then I just return. But if it's not empty, then I'll just return myself dot items at position 0. That will be my pick function. Then I'm going to do my poll function. Define poll self. Then I'll pass. So I'm going to explain what the poll function does. So this is what a poll function does. Let's go back here to paint. A poll function will take this first node, our first node in the heap. It will take it away and return it. Then what it will do, it will get this last node in the heap and bring it to the what? To be the top node here in the heap. After bringing this last node to be the top node, then it will move. Then it will what? It will rearrange. It will rearrange the nodes to make sure that the node that is here has to be less than its children. So it will heapify down. So it will heap it down, take it downwards. So if 13 comes here, 13 is greater than its children, so it has to go down. So that's what the heapify downward means. It has to go down. So after taking out this top node, it will bring back the last node in the heap, then it will heapify it down. So now let's define the function. So to define the function, we shall first check if the length, that's the length of the list, is equal to 0. So if the length of items is equal to 0, so meaning that there are no nodes in the what? In the heap. We shall just print out empty. Then we shall return. Then, what if it's not empty? Our items will equal to self dot items, that's position 0, meaning that we shall get that first node in the heap. Then I'm going to check my self dot items at position 0. I'm going to replace it with the last node in the what? The last node in the what? In the heap. So also my self dot items. Then I'm going to take the length of self dot items. Then I'm going to subtract 1. That will get for me the last element in that list, which is the last element, the last node in the heap. Then since now that element is on the top node, then I want to heapify it. I mean, take it down, check, make sure that it is less. Since I'm making a min heap, I want to check and make sure that it is less than its children. So I'll just call myself dot heapify. I'm not yet defining the function. I'll define it later down on. So I'll call myself dot heapify down. We shall define that function later on. Then I want to return my item. So that is, I want to return my item. That is the poll function. Now I'm going to define the function to add an element or one item onto the heap. So I'm going to say self, define add, then self, then item. Then after this, I'm going to call my self dot items dot append. Then I'm going to put item. Then I'm going to call heapify up, meaning that if it is supposed to be less, take it going upwards. So heapify up means heapify. I'll call my heapify up after adding it to will be the last element in the list. Then I want to take it upwards and make sure that it has to be less than what? It has to be less than its parents. It should not be greater than its parents. That's why the heapify down, it will rearrange the list until the element the new item that I've added has to be less than its parents. So now let's define our heapify up function. So we shall come here, define heapify up. It will take in self. So to heapify up, I'm going to first get the index. Now heapify up, it takes the last item we have added on the list. So I need to get the index of the last item we have added on the list. So to get the index of the last item we have added on the list, we shall call index, then we shall call the length of the list, self dot items, then we shall subtract 1, then we shall get the item, that is that last item in the list, then we shall call it self dot items, then we shall call it index. Then we are going to now check something. It's quite long. Let me bring it. So this is what we are going to check. While this index, while self dot has, this index has a parent, and the parent, this self dot parent will get for us the value of the parent, and if the parent is greater than the item, then we should do something. Now remember, the parent has to be less than the children. So this item which I put here is the child. So the parent has to be less than, not greater than. So if this index has a parent and that parent is greater than the item or the child, we don't want that. The parent has to be less than the item. So we have to swap the two. So we shall call the swap function. The swap function we defined earlier. Then the swap function will self.swap. Since we're in class, self.swap. Then the swap function we shall call get parent. We shall get the parent index, pass in the index of the child. Then we shall pass in the index of the child. So it will swap the two. So after swapping the two, now it's going to my new index, which I now want to check, will be the index of the parent. So I'll say get parent index, then it will call in index. So now it's going to go, now the parent is now the child. So it will have to make sure now that since the parent is now the child, it's going to get the parent of now the child, which was the parent. Then it's going to make sure that the parent is less than the child. So it will go it will be taking heapifying down, reorganizing the heap until it is well organized. So that's what heapify up does. That's the simple logic of heapify up. Now we're going to do another function and we're going to call it heapify down. It will take in self. Then heapify down. Heapify down comes usually, we call it from Paul. That's when we take the first element in the heap. So now we want to heapify the last element in the heap. We have brought it to be the first element in the heap. Now we want to heapify it down. So our index in this case will equal to 0. Then we're going to say while has left, let's call it self dot has left child. While this index has a left child, then my smaller child, so the smaller child is usually the child of the parent. So the smaller child index will equal to get left left child index, then I'll pass in my index. Then I'm going to make another if statement here. Let me copy it, then this will be my if statement. So this should be self, then this should be self, then this should be self. So now what we do, self dot has right child. So we're going to check if this index we have has a right child and this right child is less than the left child. It means that the smaller child is now the right child. So then we shall change our smaller child index to be the right child, index. So we shall get right child index, and we shall pass in index. Now this has to be self, and also this has to be self. Then after checking that if statement, we shall come back here, and then we shall get our smaller child. So our smaller child will equal to self dot items smaller self dot items, and we shall pass in the smaller child index to get for us the smaller child. Then our parent of the smaller child will equal to self dot items, then we shall pass in the index we have. Then we are going to now make another analysis. If the parent is less than the smaller child, then it's okay. Since we're having a mean heap, the parent always has to be less than its child. So we just end the loop, we break, and everything is okay. But else we swap the two. So we shall swap the index, we shall swap the parent, which is index, that's the parent, and then the smaller child index. Then now our index will be the smaller child index. That will now be our index. The smaller child index will be our index. Then the loop will repeat itself until everything has reorganized. That is what heapify down does. So this is how you can implement a heap. Simply you can implement a heap like this. If you have reached the end of this video and you have not understood, try going back, maybe playing the video slowly and trying to understand until you get what a heap is and how to implement a heap in Python. Thank you for watching. If you have liked, leave a like and please subscribe to the channel. Thank you.